Perhaps surprisingly, equivalence is easier to understand than implication. We give the equivalence A double arrow B the truth value 1 exactly in the case that A and B have the same truth value. Let us now look at the full truth table. We consider the propositional formula negation left parenthesis P0 or P1 right parenthesis double arrow left parenthesis not P0 and P1 right parenthesis, and we write the proposition symbols that occur in this formula to the leftmost columns of a truth table, and then form a row for each possible combination of truth values of the proposition symbols. There are 4 rows because we can distribute the values 0 and 1 in 4 different ways to the proposition symbols P0 and P1. To the right, we form a column under each occurrence of a proposition symbol in the formula as well as a column under each connective. Every connective in a formula is the main connective of some subformula. The truth value that we write under that connective is the truth value of that subformula. Let us see how a truth table is built. First, we fill in the proposition symbols. We just copy them from the columns on the left. Then we fill the column of negation. That is easy, just swap zeros and ones. We can only do this for the negation on the right, because there the negation is applied to the subformula P0, whose truth value we already know. Now we can fill in the conjunction. Note that the conjuncts of this conjunction are not P0 and P1. So we have to look at the columns corresponding to not P0 and P1. Now the disjunction. This is a disjunction of P0 and P1, and we look the values from the truth table of the disjunction connective. Next, we deal with the negation on the left. Note that we cannot compute the column of the equivalence symbol before we take care of the negation, because not left parenthesis P0 or P1 right parenthesis is an immediate subformula of the big formula. Finally, the equivalence. The truth table of the given formula is now ready. We can see that the formula gets value 1 if P0 has value 1, and otherwise it gets value 0. This can be a very useful piece of information. All that complicated sentence is trying to say is that P0 is true. Here is a bigger truth table. This is built just like the previous one, column by column, starting from the proposition symbols, going up to bigger and bigger subformulas, always inserting the truth value of the subformula beneath its main connective. First, the proposition symbols. We simply copy them from the left. Then we start filling in the implication columns by using the truth table of implication. Remember that implication is true, except in the one case that hypothesis is true and the conclusion is false. Now we have filled in 3 implications, and we can fill in the conjunction on the left. There is only one implication left, and now we fill that in. It is an implication of the conjunction and the implication. So we have to look very carefully what the truth values are on each row of the conjunction and the implication on the right. The truth table is ready. At first look, it may seem that the propositional formula in question is incomprehensible, as such a long formula might very well be. As it happens, this formula seems to state a kind of transitivity of implication. If P0 implies P1 and P1 implies P2, then P0 implies P2. Be it as it may, our task here is to fill in the truth table quite mechanically, with no concern to any exterior meaning. But we can make the interesting observation that the formula in question gets the truth value 1, whatever the valuation is. We have a special name for such formulas, quote, tautology, unquote, and we will pay special attention to them in a while. Truth tables become eventually too large. If we have n proposition symbols, we are going to have 2 to n rows in the truth table. Thus, the truth table grows exponentially in the number of proposition symbols. This limits the applicability of the truth table method in practical applications. During this course, we learned 2 other methods to analyze propositional formulas. Those other methods will be a bit more complicated, but at the same time quite a bit more useful.